in the middle of 1A, which is fine. Okay. We were working on given polar coordinates, trying to find our rectangular coordinates. So we were given r and theta, and our goal is to find x and y. And I suggested we use those 4 conversions, right? And so on that first one, we were given r and theta, so we used x equals r cosine theta. We found x to be either 5 square root of 3 over 2 or the decimal 4.33. Remind me at the end, I will check homework and see what form I have the homework answers in, because I don't remember off the top of my head. But, I mean, both are good. I would probably say the 5 square root of 3 over 2 would be better. So that's my x coordinate. How am I going to find my y coordinate?
Same thing, but with sign.
Yeah, we're going to do the same thing. We're going to do y equals r sine theta. So y equals r, which was 5, times sine of pi over 6. Now, this is where I encourage you guys, don't go straight to the calculator. Okay? So it's 5 times, what is sine of pi over 6? According to our chart, it is 1/2. What's 5 times a half? 5 halves is what you're usually going to see me write. Now, if you want it as a decimal, it would be 2.5. Okay, so we found our x value and our y value. I would write that your final answer as an ordered pair. So you could either write in an exact form, which is the 5 square root of 3 over 2, comma, 5 halves, or you could write it as a decimal, 4.33, comma, 2.5. I do have both in my notes, I will say that. Now, before we move on to the next one real quick, I want to talk about, does this answer make sense? Like, did we do this right? Does this make sense? So it kind of helps us if we know if we did this right. Let's talk about the original problem, 5 comma pi over 6. Now, I don't have all the fancy here, but you get the idea. 5 comma pi over 6. Where would pi over 6 be? Pi over 6 is quadrant 1, something like that, right? 5 out means you would count 5 rings out. I don't have the rings on here, but it would be something like that, yes? Now, we'll talk about that later. Does this make sense with the rectangular coordinates we got? 4.33, 2.5. It puts us in the same quadrant. It puts us kind of in the lower half of the quadrant, right? Yeah. In the lower portion of the quadrant. So
it puts you far out enough that
yeah, it puts it to where it makes sense. So I'm not necessarily saying you have to do that in homework, but it's just a good check to see if it makes sense and whatnot. Okay? Questions on that one? Okay, let's talk about B and see if there's some negatives in there, what we're thinking. So we have the ordered pair -6 comma negative pi over 2. So -6 is my what value? R value. Negative pi over 2 is my theta value. You guys know what we're going to do, right? We know r and theta, so we can use x equals r cosine theta to find x. So x equals -6 times cosine of negative pi over 2.
Really just 3 pi over 2.
Okay. And you do need to think about that, yes? Negative pi over 2. And you could rewrite that if you want. I'm not saying you'd have to do this step. But you can think about this as 3 pi over 2. You don't have to write that step in. But just realize, negative pi over 2 would be down here. And so that is 3 pi over 2, yes? What is the cosine of negative pi over 2 or 3 pi over 2, whichever way you're thinking about it?
0.
0, because remember, what's the ordered pair here?
0, negative 1.
0, negative 1. In an ordered pair, it is cosine sine. So cosine of 3 pi over 2 is 0. What's negative 6 times 0? 0. So there's our x value. What about our y value? Y equals r times sine of theta. So negative 6 times sine of negative pi over 2, which, if you prefer, same thing, right? Sine of negative pi over 2 is the same thing as thinking of sine of 3 pi over 2. What is the sine of 3 pi over 2?
Negative 1.
Negative 1. It's the other half of that ordered pair. And negative 6 times negative 1 is 6. So what is our rectangular coordinate here?
0, 6.
0, 6.
How does that one make sense though? Then?
Well, let's talk about it. Negative 6, negative pi over 2. Negative pi over 2 is this angle down here, right? So here's my negative pi over 2. But what does an r value of negative 6 tell me to do? 6 circles out, but because it's negative, you go
The other way.
backwards through the pole, so you're going to end up going 6 up, right? The angle, whether it's positive or negative angle, you just have to find that angle. The negative r value ends up taking you to the other side of the circle. So now does it make sense?
Yeah.
Yeah, because that is 0, 6. Okay? And again, I said, you don't necessarily have to, you definitely don't have to write this down, I don't think, unless there's something homework that requires you. But it's a physical, it's a, okay, think about it. Does it make sense? And I hope in the process I'm trying to get you guys to make more connections between rectangular coordinates and polar coordinates. Okay, guys. You know how to take polar coordinates to rectangular coordinates, yes? Well, guess what? Let's go the other way. So now we're going to take rectangular coordinates, which are given, and we're going to find our polar coordinates. So rectangular coordinates are given. That means x and y are given. And we're trying to find polar coordinates, which means we're trying to find r and theta. Now, you might look at this first part A and think, oh, those are fractions, radicals, yuck. But in reality, they're good values for what we're doing. Okay?
Yeah. So I would say we use the fourth one, the x squared plus y squared equals r squared. We can find r, and we plug them both back into the two equations we just used.
I'll take you a different way than that. Would that work, though? I'd have to make sure that would work.
Because you could plug r in for r, and you already have x and y. Then you just find theta.
Yeah, I'm going to go a different way with it, but
Right.
I see what you're saying. Off the top of my head, I think it would work. But, okay. Regardless, in order to find r, you need to use the one that's basically the Pythagorean theorem, right? So the idea that, I'm going to reverse it, r squared is equal to x squared plus y squared. Okay? Do the math with me. Don't be afraid of it, please. You guys can do this. You're in pre-calc. Have confidence. X squared means I'm doing negative square root of 3 over 2, quantity squared, plus y squared is 1/2 squared. Hey guys, negative square root of 3 over 2, negative square root of 3 over 2, quantity squared. A negative squared is going to be a positive. When you square square root of 3, you're going to get 3. And 2 squared on the bottom is
4.
4. So 3/4 plus, what's 1/2 squared?
1/4.
1/4. 3/4 plus 4/4? Nope. 3/4 plus 1/4 is 4/4 or 1. If r squared is 1, what is r?
So -1.
Officially, it is plus or minus 1. Okay? Now, with that in mind, hold on to both r values. We're going to need both r values. Okay? So hold on to those values. And so I guess, Logan, this is why I would not say, no, we don't want to go the x equals r cosine theta and y equals r sine theta route, because we have 2 r values to work with.
Yeah.
Okay? And we have to figure out what goes with what. Now, what's the other conversion equation we haven't used?
Tan theta equals y over x.
Yep. We're going to use that one. So tan theta equals y over x. In this scenario, it's not going to be pretty for the first moment, but it will become pretty. Okay? Y is going to be 1/2 divided by x, which is negative square root of 3 over 2. Yes? Okay, guys. What about a fraction divided by a fraction? Uh-huh. So, tangent theta is 1/2. Division becomes multiplication. Flip. And it's a negative of 2 over the square root of 3.
See, I don't mind cross canceling here.
Okay. What does that become?
1 over square root of negative square root of 3, which would really be like negative square root of 3 over 3. With
Okay, pause there. Okay. So we cross cancel the 2's. You guys with me for negative 1 over square root of 3. Now, I've asked you guys to be familiar with 1 over the square root of 3. You should be familiar with 1 over the square root of 3 is the same as square root of 3 over 3 when you rationalize it, yes? Coincidences on our chart? Definitely not. So this is the same as saying tangent of theta is equal to negative square root of 3 over 3. Now, I need to find theta.
I would say pi over 6.
So we want to know, when does tangent equal square root of 3 over 3? But then we have to throw in the negative twist. So first of all, pause. Forget the negative for a brief moment. When does tangent equal square root of 3 over 3?
5, 6.
Pi over 6. Everyone with that?
Yup.
But that's not an answer because tangent is what? Negative. Now, it's back. All students take calculus. So we just talked about pi over 6. That's the angle you need to think. But I need to think about it in my negative quadrants. Where is tangent negative?
2 and 4.
In S and C. Not in all and not in T, right? So what are we asking for? What are the pi over 6 angles in those 2 quadrants? They are what? 5 pi over 6 and 11 pi over 6. Now, okay, guys. We have 2 r values and 2 theta values. What we have to figure out now is which r value goes with which theta value. Because what's going to happen is we're going to have two polar coordinate answers. Because you remember yesterday I talked about how there's multiple names for every ordered pair. Because whether you go in a positive direction to get there or a negative direction, whether you go forward on the angle or whether you go backwards through the pole. So earlier I said, you don't necessarily have to think about it. Now we do. Where, just generally speaking, is the point negative square root of 3 over 2 comma 1/2? Generally speaking, it is in quadrant 2, yes? Okay, my hope is that you can agree that this is in quadrant 2. So match an R value and a theta value to create an ordered pair that puts me in that angle. So what angle would that be then of these two?
1, 5 pi over 6.
Okay, so this angle is 5 pi over 6. If it's 5 pi over 6 in this quadrant, then that is a positive 1. So 1 comma 5 pi over 6. How would 11 pi over 6 make this happen?
Because negative 1, so you're going the opposite way, so it ended up in quadrant 2 also.
11 pi over 6 is this angle down here in quadrant 4, but a negative 1 would shoot you backwards through it. So you're going to put negative 1 and 11 pi over 6 together. This is 1. Maybe you won't necessarily draw that picture, but do you have to think that through? Yes. Did I make that make sense? Okay, it's really just trying to look and see, okay, how can these pair up? How can they make the same points? Okay, you ready to try the next one?
Yeah.
Okay. Again, what did they give us? It's sometimes, in this situation, it's hard to tell what they gave us. Is this polar or rectangular? Vocab says this is rectangular, right? So this is x and y. So we know x and y. We can start off, easiest part is to find r. R squared equals x squared plus y squared. So r squared equals negative 3 squared plus 0 squared. Okay, guys, what is negative 3 squared? 9. Plus 0 squared is still 9. If r squared is 9, what is r?
Plus or minus 3.
It could be a positive or a negative 3. Depends on the angles we come up with. Okay? Now, use tangent. Tangent of theta is equal to y over x. So in this scenario, tangent is equal to 0 over negative 3. What is 0 divided by anything?
0.
0. Your calculator will tell you that, but you're at that point in your life, I just need you to know that. Okay? Now, can your calculator remind you though when you forget? Yes, if you have calculator, use it. So 0 divided by anything is 0. Okay, guys. We need to know, when does tangent equal 0?
0 pi.
Why?
Because the numerator is 0, because the y value would be 0 on those.
Okay.
It can't be the other two because the denominator is 0, which makes it not possible.
Okay. So the key thing to look for, when you talk about tangent equals 0, obviously when we talk about a 0, it's going to have to be one of our 4 quadrantal angles, right? But notice, this is a good thing to look at, you're looking for when is y 0. Okay, so that's the key, is when does y equal 0? And when we start looking at when does y equal 0, that happens here at 1, 0, and here at -1, 0. Am I making sense? Okay, I like the answers. I just got to make sure we get to them. So I agree with 0 and pi. Now, question is, give it a moment of thought, how do your R values of 3 and -3 go with my angles of 0 and pi based on, where is this original ordered pair? -3, 0? That's your rectangular coordinates, yes? So we need to make plus or minus 3 and 0 and pi make it happen. Well, what angle is this? This is pi. If that is pi, that means you're going out how many?
3.
A positive 3.
Well, and you notice the other one is already over there.
Okay. That doesn't mean they're the same, though. You have to be careful there. Okay. 0 is going to be over here, but we need our dot to be on the left. So an angle of 0, when you shoot it back through, is -3. Now, I don't have a counterexample off the top of my head, but I would caution the idea of what he just said that, oh, well, the original is -3, 0, so one of these is -3, 0. We're talking two different scenarios here, and I can't guarantee that would always work. Okay, so just be careful. Okay. One more problem. You guys remember the distance formula that you learned like back in middle school?
Square root of x2 plus x1 squared plus y2 plus y1 squared.
Yeah, pretty much, except it was x2 minus x1 and y2 minus y1 in there, but right idea. Okay. Well, we have an equation that not exactly like that, but it's from the general idea. So the distance formula for polar coordinates. Now, this is based on having two polar coordinates. So the idea of an r1 theta 1 and then not r squared, r2 theta 2. Okay. So d equals, guess what? It's the square root. Now, as I said, it's not the same on the inside. R1 squared plus R2 squared minus 2 times R1 times R2 times cosine of theta 1 minus theta 2. Now, really what this is? It's a law of cosines problem. Law of cosines, if you remember law of cosines. Okay. You know that distance formula. This really is just going to be a plug and chug, yes?
Yes.
Okay. What is provided? R1, theta 1. R2, theta 2. That's what's provided. I'm just labeling them so we know. Are you ready to go?
Yup.
I'm going to start with D equals, and it's going to be a square root. R1 squared, so I'm going to write it out before I do any math. 2 squared plus R2 squared, 4 squared, minus 2 times R1, which is 2, times R2, which is 4, times the cosine of theta 1, 5 pi over 6, minus theta 2, pi over 6. Okay. We do some cleanup here.
Yep. Equals
2 squared is
4,
4. What's 4 squared?
16.
Can we put those together?
Yep.
2 squared plus 4 squared. So 4 plus 16 is 20. Minus. No, you cannot subtract those values right off. That minus 2 times 2 times 4 is attached to the cosine. I say this because some of you were doing this in the last chapter. Okay? So minus, what's 2 times 2 times 4? 16. Cosine of, what's 5 pi over 6 minus pi over 6?
4 pi over 6, pi over 3.
Okay. 4/6 reduces to 2/3. Okay, keep going. At least one more step. No, I cannot do 20 minus 16 because 16 is attached to the cosine. 20 minus 16 times. Okay, guys, we're doing this by hand first because I want to make sure you can think about it. Cosine of 2 pi over 3. That means, which angle for my chart am I using?
Pi over 3.
Pi over 3. But then so pi over 3 is here. We need the 2 pi over 3, which is here, yes? That's the one we need. So we need to know what is the cosine of pi over 3, but in quadrant 2. Okay? Cosine of pi over 3 is 1/2. What about when we start talking about it in quadrant 2? All students take calculus. Sine is positive, that means cosine is negative. So now, where are you at?
It would be 20 and then 16. Negative 16 times negative 1/2 would just make it plus 8. And square root of 28
Okay.
would be reduced to 2 square root of 7.
Okay. 16 times half is 8. Negative times negative is positive. Plus the 20. So 28. I do agree it's 2 square root of 7. How do I have... And then as a decimal, could you get the decimal?
You could.
You could. And I have it as a decimal on my paper, which means that might be what the answer key has. 5.29. Now, and I will say, I'll double check the answer key here in a moment. I do only have that answer circled. If your directions tell you to round to the nearest tenth or something like that, or hundredth or whatever, that means they want decimal, yes? Could we have put this in the calculator earlier on? Technically, yes, you could.
Maybe you can always put it
So.
in the calculator. That's what I'm saying.
Okay. Your homework. Looks like a lot. I think it's 20 problems.
That's a lot.
You'll be fine.
I can't finish that at home.
Okay. Page 484, 1 through 4, 7, 8, 11 through 14, 27, 31 to 34, 51, 52, 58 through 60. I forget what numbers it's for, but I am going to give you a piece of graph paper that I believe is for 7, 8, and 11 through 14. I think those are the ones that go on the graph paper I'm getting ready to give you. Yes. Okay, so 7, 8, and 11 through 14 will, those you just need to graph the point. Okay?